Hello and welcome to uh, day 3 of chapter 2, which we're going to talk about solving differential linear equations, specifically first order linear equations. And so last section we talked about solving a differential equation in terms of separable variables. That was very similar to what you did in Calc 1, Calc 2. Today we're going to kind of start some new stuff, and we're going to figure out, okay, how can I solve a differential equation that's represented as a first order linear differential equation? And so the first thing that you're going to want to do is if it's in this form, you want to get the dy over dx by itself. And so when we do that, we're going to divide everything by that, a sub 1 of x. So to get dy over dx by itself, the first thing you're going to do, if it's not already in standard form, you're going to go ahead and divide that leading, coefficient, which is a function, and you're going to divide everything by a sub 1 of x. All right, when you do that, then what you're going to have is you're basically going to, this is going to go away, and it's going to be in standard form, where your p of x is going to be a sub 0 over a sub 1 of x, and then your f of x is g of x over a sub 1 of x, and we'll work on it that way. So the first thing that you're going to want to do when you're solving a linear first order equation is you're going to make sure that you have it in standard form. So you're always going to be your first step. So if you recognize, okay, this is a first order differential equation, a linear differential equation. Again, linear, go back to our chapter 1 notes, is that it's in descending order, and then every function of this is going to be a sub 1 of x, a sub 0 of x. And that y is not 2 like any power. So if we divide both sides of the equation by the leading coefficient, a sub 1 of x, we will obtain a standard form of a linear equation, so what we just did. Now, these are the steps to solve a linear first order differential equation. All right, so to solve a linear first order differential equation, we want to first put it in standard form. After we put it in standard form, we're going to find the integrating factor, which is this e to the integral p of x dx. I'm going to show you why we use that in this, right below here, but that's the next thing that we're going to find once we put it in standard form. All right, now it's not hard to find. It's just that value, that coefficient that's in front of y, that's going to be now the power inside of an integral of an exponential. And so once we find that, we're going to multiply both sides of the standard form by the integrating factor, and then we're going to rewrite the left-hand side as the product rule of two functions, and then the right-hand side, we're just going to have it, and then we're going to integrate both sides and solve for y. So it sounds pretty easy, and it really isn't that difficult. We just got to be able to find e to the integral p of x dx, which is very easy to find. Then we're always going to put it in this form, and I'm going to show you why we're able to put it in that form. And that's because we're multiplying by this integrating factor, and then we just integrate both sides and solve for y. So it's something that's not really complicated at all. All right, so why do we multiply by the e to the integral p of x dx? Well, because on the left-hand side, what we want to do is, if our functions of this format, dy over dx plus p of x y is equal to, the right-hand side we said was f of x. If we multiply by an integrating factor, so we multiply everything by that, we're going to get e to the integral of px dx dy over dx plus, and then we have e to the integral of px dx times y. That's equal to e to the integral of px dx. The whole reason we want to do this is because we want to make sure that we can write the left-hand side in terms of a product rule. All right, now, I don't like, using p of x, but just because, I'll do is I'll make it bold as I write this. So you can speed up if you want to. It's going to take some time to write it in bold. So another way to rewrite this is going to be this, all right? Now, the integral of px dx is going to be, wait, I forgot to write our px times our y, all right? So one way to write this is going to be e. Now the integral of px dx is just going to be the, just cap p, but we're going to do that in bold. P of x. And then times dy over dx. Plus, and then we have e, and then again, I'm just going to put it in cap p of x. So this is, the integral out, written out. And then p of x, because when you see it, in this thin, it's just this right here is the derivative of that because it was the integral times y, and that's equal to e, and then we can go ahead and make that, cap p of x. We did the integration. X. And then I realized I forgot to write the f of x there. I don't know why I wrote that there because I did the integral. So times right there. All right, well, on the left-hand side, what we have is it's the product rule. So d over dx is just going to be e to the p x times y is equal to e to the px times f of x. And that's how we get to this part right here. And so again, that's why we're multiplying by the integral of px. We can kind of look at p of x, the one that's not in bold, we could look at that as like p prime, because that's a derivative of, what's going to be in the exponent because we're taking the integration of that. So we're, one step above p of x. And so that's why I put that in bold. And so, when we introduce this integrating factor over down here, we can rewrite this entire left side. We can rewrite this entire left side as the product rule, all right, of e to the p of x times y. Right? That's why we want to introduce that integrating factor. And then after we introduce that integrating factor, once we've introduced that, all right, then what's going to happen is we're told, okay, now we got to integrate both sides. When we integrate the left side, that integration and that d dx is going to cancel each other out, and we're just left with e to the power, and I should put that in bold, e to the p of x times y is equal to, and then we'll have to integrate the right-hand side. So that's why we're introducing that integrating factor, so that we're able to write the left-hand side in terms of a power rule. And write the d of x there, so just have it. And then it's not going to be, that difficult after we write it all out.